Hi there, my name is Qingxiao Zheng, a doctoral student at the University of Illinois at Urbana-Champaign. In this presentation, I will share our literature review of ACM papers that address user experience research on conversational human-AI interaction. There is extensive literature on conversational agents or chatbot, which are referred to as CAs in the rest of my talk. Early CAs focus on dyadic human-AI interaction, which involves only one-to-one interaction between humans and their CAs. In recent years, polyadic human-AI interaction is gaining popularity. Unlike dyadic interactions, polyadic interaction aims to support or mediate human-human interactions. So, what motivates this study? First, polyadic CAs are unique to design. They encompasses a wide variety of complexities that dyadic interaction may not encounter. For example, multi-party interaction, social role-taking, group hierarchy, or social tension. Second, most prior empirical studies and reviews focused on dyadic CAs without addressing the unique design challenges of polyadic CAs. Therefore, in this literature review, we focused on examining how polyadic CAs are designed and evaluated to fill the gap. In particular, our research questions focused on understanding the fundamental challenges of human-human interaction that are addressed by polyadic CAs, research interests between dyadic and polyadic CAs, the practices of designing, the effects of using polyadic CAs, and the evaluation metrics. Findings can be helpful for researchers and practitioners to identify common practices, research gaps, lessons learned, and promising areas for future advancements. Our literature review has four stages: definition, search, selection, and analysis. So first, in the definition stage, we develop a series of criteria. We use them to include UX research on conversational human-AI interaction, such as the articles are research papers with user studies. The major design feature is conversational based, and the CA interaction in the article is bidirectional. Also, we identify data sources by piloting 200 papers from 5 different digital libraries. We chose ACM Digital Library because it features a wide selection of reliable HCI works. We searched the queries through ACM using CA synonyms, web crawled metadata, and converted PDFs of papers to build our dataset. After removing duplicates and going through the paper screening, we identified 36 papers that design polyadic CAs and 135 papers that design dyadic CAs. We then used mixed method and conducted thematic analysis and topic modeling to analyze the data. Moving to the result, we found that polyadic CAs were designed to resolve inefficient communication. For example, because online teams are often less organized, reaching consensus can be time-consuming and discussions are hard to organize. Also, inactive engagement was identified as a common issue. Besides, building and maintaining social connections and identifying common grounds can be challenging. Polyadic CAs were proposed to address these challenges. Through analyzing proven effects, we found that, first, polyadic CAs can help with consensus reaching, aid communication comprehension, enhance task management, and save time and energy of human collaborators from tedious work. Second, they benefit group dynamics by encouraging engagement and balancing uneven participation. Third, they help in regulating team emotions by encouraging users' positive attitudes. Lastly, they can build balance and solidarity in the group by showing agreement, disagreement, or bias towards one side. We also looked at polyadic CAS application domain, modality, characteristic of embodiment, the originality of design, etc. Some aspects involve only multi-user interaction, which are unique to polyadic CAs. We created a new aspect of relationship type, which was not found in prior work. It contains subcategories of co-learners, co-workers, co-players, first mates, and etc. We also synthesized metrics researchers use to evaluate both polyadic and dyadic CAs and categorize them into chat log analysis, survey scale, and interview. Chat log analysis use a conversational log or code user behavior through watching recorded videos. These metrics reflect language patterns appear in connected speech and are related to conversation structure and flow, task fulfillment, and model training, as well as user perception and behaviors. For survey scale metrics, they evaluated user perceptions on CA's dialogue management, adherence to social protocols, system usability, and user experience. For interview analysis, users were interviewed regarding their general impression on CA, perceived CA capability in handling requests, CA personality, and their behaviors and efforts used. Also, some overlooked issues we found can be inspiring for future design guidelines. They relate to appropriateness, privacy, and ethics in the design of CAs, which warrant deepened discussion about the role of polyadic CAs, their social influence, their relationship with humans in different group settings. Overall, we found a very small fraction of CAs published in ACM venues designed for polyadic human-AI interaction. This literature review mapped the progress in this field for future researchers. We also bring about the social boundary issue. So, boundary in social science can be understood as a set of rules followed by most people in a particular society, which are vital in society because they can guide human behaviors and assist in managing what is and what is not acceptable. This issue is closely related to privacy and disclosure, as the presence of polyadic CAs as social actors changes the social dynamics and uses information management strategies. We also discuss a research agenda for future communicative AI technology. For example, to advance relational dynamics, which reflects the ways people interact with technology, with themselves, and with other people and a group of people. We suggest that polyadic CA can be further investigated in their effectiveness to foster new relational dynamics. Finally, I would like to thank my fabulous collaborators, Yiliu, Yiren, Weizi, and Yuan. On behalf of our team, I would also like to thank our funding agencies, the National Science Foundation, and the IBM Illinois Center for Cognitive Computing System Research, a research collaboration as part of the IBM AI Horizon Network. Thank you.